Previously, we discussed statistics, which are characteristics of samples. We looked at measures of central tendency and measures of variation. Typically, the data we will have will be a sample drawn from a population. We won't have all of the data from the population. But remember, we want to use our sample statistics to make inferences about the population parameters. So let's look at those population parameters. Okay, so for our different measures, we had statistics. So for the mean, our statistic, the notation for that was X bar. And for our parameter, we need a different notation, and we use Greek letters, and here we use the Greek letter mu. Okay, and then standard deviation. And we said our statistic was S, and so our parameter is the Greek letter sigma. And finally, we looked at the variance, which we said was S squared, and so not surprisingly, the parameter would be, the symbol for that is sigma squared. So let's talk about how we would calculate these. Even, as I said, we normally don't have that population data, but it's still important to understand how those would be calculated if we did. So for the mean, we said that to calculate the mean of a data set, we just take the sum of all the individual values and divide by n, where n is our sample size. Well, for mu, the calculation's the same. You just add up all the values in the population and you divide by the size of the population, and we use the capital N to represent population size. So the mechanics of the calculation are identical, whether you're talking about the statistic X bar or the parameter mu. Okay, let's look at standard deviation. Alright, so we had our formula. Recall that we were taking the difference between each value and the mean. We get the square of that, divide by the sample size, minus 1, and take the square root. So the difference then between that calculation and that of sigma has to do with the denominator. We still take the sum of each value in the population minus, now instead of X bar, we have the population mean. If we have all the data values, we should have the population mean, and now we just divide by the entire size of the population. So that's how we, in the parameter, the computation for that parameter. And then of course we can just look alongside that at our variance, because recall that the variance was just S squared, so it was just squaring both sides of this. Which just in turn gets rid of the radical. And same thing here for sigma squared then, when we square both sides. That would be our calculation. Now, I mentioned previously that there was something called an unbiased estimator. I mentioned this when I was talking about the variance, and advantage of the variance in that it's an unbiased estimator. So let's get an understanding of what that is. This is a sample statistic that tends to target the population parameter. So in other words, it doesn't tend to overestimate or underestimate that population parameter. And so what I said before was this is true for the variance. So we would say that S squared, that statistic, is an unbiased estimator of sigma squared. It tends to target sigma squared. And this is also true for the mean. So X bar is an unbiased estimator of mu. But the standard deviation is not considered an unbiased estimator. It is a pretty good estimator, but it's not unbiased. So why do we choose that as our measure of variation over variance? Well, recall units. The units of the standard deviation are the same as the units of the data, and in fact the same as the units of the mean. However, if we square standard deviation and get variance, now we have units squared. So that's the difference, that the standard deviation has the same units and makes our work a little easier. It's not an unbiased estimator. The standard deviation is not unbiased. However, it's not terribly off. So we do go ahead and use that. But it's important to know what these unbiased estimators are, and so far from what we've seen, of the statistics we've seen, the variance and the mean are the two that are the unbiased estimators.